Hello guys, how are you doing? So today we are going for our second video on the course. Now it's the first practical video. So today we are going to really start to build our first application. It's going to be the desktop, or it's like a embedded application which is going to communicate with our APIs. So this application will be created with the idea of being running on a machine, which is going to be controlling the camera, would be controlling the camera and the detector and everything to make the real detections of the vehicles which are driving on the lane, on the streets. Okay, so first, so as I said, we're going to use Spring. So let's go through Spring Initializr. I will set up with Java. Groups going to be those dev email. Here is going to be detector app. That's it. Java 21. Dependency, what are we going to use? Let's use grow native support. We are going to run this to build natively. What else? So we are going to have Spring Web. That's not a web application. We are going to have a database. I think that's pretty much it. There's not much. I think test is already included. Test containers. Yeah, we won't need that test containers right now. Let's start simple. Let's just generate with GraalVM native support, and that's it. So now what I'm going to do, I will move this to my workspace and move this to course. Oh, there's already something there. Oh, let me remove the old one. Start from scratch. So here, cool. So we have our detector app. Let's go. I'm using IntelliJ community here. But yeah. Okay, let's open our application, workspace, here, and detector app. Cool. Okay, so I'm already assuming that you already have Java set up on your machine. So if you don't, I may create another, I may just add some links, or I can create another parallel video just to show how you can install Java, but I expect you to already have the Java 21 running there. So we already have our project. So let's just first run it, see if it's running fine. Yeah, all good. So it's running here fine. Let's then start with the basics of our application, right? So as I mentioned to you, the first thing our application is going to do is to make a detection. So first, let's create the domains for our application. So I will create inside the package called domain. I will create a detection record. This is going to represent our detection itself. So what the detection is going to have is, first it's going to have an ID, unique ID, identifier. What else it's going to have? It's going to have an instant. So time. So when exactly the detection was made. What else? We're going to have long speed. That's the speed the vehicle is driving. We're also going to have a plate for the driver itself. So ID, plate, speed, and we can also have here another, which is going to be the equipment. Let's create a new class, the record equipment. It's also going to be inside the domain. So the equipment is basically going to be the machine where this application is running, right? So that's the main concept. So if you think about it, let's have something here. So just for you to understand. So we are going to have an equipment. It's going to have, imagine this as a machine, as a computer running. An equipment is going to be running on a place. So there's going to be a location where it's going to be running. It may also have an ID and etc. But the most important thing is the location. It's going to have at least some configuration as well. It's going to have a list, so let's say 1, 2, multiple lanes. So it's maybe running on the street which has 2 lanes or 3 lanes, for example. So there's one equipment. It may also have For example, one equipment may have, as soon as they have lanes, or yeah, we can say like this, for each lane, one to one, we are going to have one lane has one detector. Let's call it that, because like as I mentioned before in the previous class, we should be taking care of a camera and a detector itself. But here, since we are not going to use camera and pictures and everything, let's just have the concept of a detector itself. So every lane, one lane, there's one detector per lane. So imagine there's a laser pointing to the street, to the lane itself. When a car, for example, passes by, there is going to be a detection. So we take a picture, we are going to basically read the plate of the vehicle, we are going to read the speed of the vehicle, we know the time when it happened, and we know which lane we are running. Yeah, so we have one detector and that's it. So one detector will have a list of detections. So let's say here, let's create our equipment. Let's say it's going to also have an ID. It's going to have a configuration, but let's not care about configuration right now. We just have the ID. Then detection. We have the ID, plate, speed, time, and equipment, which this detection was made, or even we can say already the lane. You can say the lane. Then the lane will have the equipment. Oops, lane. Then let's create. Oh no, not class. Let's have a record lane, and the lane is also going to have here lane. Here we can like name ID. This is going to be a sequential one. We are going to have like 10 lanes. That's I had never seen it, but let's have an identifier, or yeah, identifier for the lane itself. What else? We are going to have the link with the equipment itself, so we know which equipment this lane is running on. And yeah, let's just have it for now. So detection is going to have so detection was made on a lane, a specific time, it detected some specific speed and some specific plate, and that's it. And then we have the identifier. So I think that to start, our domain is quite like defined. Let's start to have our let's start to have our classes to make the real logic. So I create like a layer here, service, then I will have detection, then I will have the name of the class going to be, let's create an interface, detector. So basically what detector should be doing is it's going to make a detection. Or in fact we can think on two ways. We can have a detector we can have a detector which basically we will call the detector and say, hey, detect, which if you think about it doesn't make much sense, because a detector should be something which should be running, and as soon as the detector detects something, it's going to be calling a callback, if you think about it, right? Make more sense. So you register a callback, the detector detects something, and it makes a call to one function to like a callback. So let's do instead the following. So the detector, it can start, it can stop. So a detector can start and it can stop, and there will also be a method called onDetect. So you can register your callback. For this, we're going to have a consumer of detection. Let's call it processor. Okay, so we have the definition of what a detector should look like. Now let's implement our fake detector. This is going to implement our detector. And then here what we are going to do right now. So first let's consider that we need to have a processor. We are going to have, let's keep the processor here. So private final consumer of detection processor. In fact, I'm thinking I'm going to remove this from here. I think the design won't look, because I wouldn't like to have this based on a method, I will have this on the constructor itself. So I remove this on the definition, so detector can basically start and stop. That's basically the definition, the contract of a detector for now. And then in here, what we're going to do is, let's create a constructor which receives a processor. And when the processor starts, as I said, let's make it very simple. So the processor is going to basically start. Let's do a while true. We are going to make it better right now. Just give me a minute. Then we are going to have a processor dot accept, and we are going to be generating one detection. So what the detection is going to have, let's generate a new random ID. Then we are going to have, what else, the plate. For the plate itself, let's just add an empty. We are going to do it later. Also 100. And then here we have the, what else is it? The last one is the lane itself. So lane, let's also receive the lane here. As soon as we create the detector, detector should already know which lane this is running on. So lane, constructor parameter, find lane. Okay, and then here we have this dot lane. What is the problem? Oh, it's the instance first. Now, and then we have the lane. Fine. So that will be the first initial thing. But that's the first problem we already have. We already have is I don't want to have a while true, right? Like when is going to stop. Also, we need to give the control for an external caller who is using this object to stop the detector to run. So a simple solution I will create here for us is to have a so when we have okay, before that, let me go back. Before fixing this error of while true, I want to do another thing. I want to run this whole process into a different thread. But I don't want to run this on a thread, like creating a thread and starting it. I would like to use executor service. So why? Because this is going to manage the threads which are running, and we can make it also pretty much flexible. We can run this with a single thread. We can run this with multiple threads, whatever we want. It's easy for us to change. So let's make it with this in mind, a bit more flexible. So here, and what I'm going to be doing is, in fact, only start. I'm going to be submit, and in submit I'm going to be running this while true here. So as soon as someone starts, we are going to be starting a new thread or whatever. We're going to submit a function or like a block of code to be executed on the executor service. It's going to be, if it's going to be executed on a new thread or a single thread or multiple threads, that's not our concern right now. That's why we are also removing the responsibility of the detector itself to know how this is going to run. So that's why we receive the executor service here. So we are basically going to submit a task, and this task is going to be running for now, forever, and generating processors, like a detection, sorry. So now what we're going to change. I need to have a way for me to, when I call stop, I basically block and stop this while execution here. So what I'm going to do here is to use atomic reference. If you see one thing here, when we call submit, it returns to us a future of something. So let's have it here. Final var execution. And here what I'm going to do, I'm going to create an atomic reference of future of something, and it's going to be process or detection running. Going to start this here. Atomic reference. So this, we are basically going to be using that in case someone calls start or stop with different threads. With atomic reference, we ensure that we are picking up this value, like the fact of using or getting the value from this variable here is thread safe. So we can, there are also some methods for us to change this in an atomic way. So that's why we are going to use it. So first thing what I'm going to be doing here start is first if this dot detect running dot get, if this returns a, like let's say if it runs something different from null, or I mean if there is some future there inside, we are basically going to, or so this, if this is null, or let's do another thing, that's something better. So final var is running, or process running, so if process running is different from null, and or wait, if this is different from null, and this, in fact let's do the following, equals to null, let's make it simpler, if this is equals to null, or this dot get, not this already get, this dot is cancelled, then we can start. That's basically the thing to be. So what does that really mean? So there are two states which this atomic variable can be. It can find calls, what processing run is not to be null, oh, yeah. Or if this is null, or process running is cancelled. So meaning that when we start, like when we instantiate our class, our object, we are going to have this atomic reference as null value. So if you call start, this is going to be starting the process, it's fine. But if, for example, someone comes and stop it, this is not going to change this to null, or the value of this variable is not going to change to null, but it's going to be canceling the future itself. And then we can call it by process running is cancelled. So we know it's cancelled, and then we can start it again. So what we are going to do afterwards is, as soon as we identify, we create, we submit the task to run, while true here, we are also going to change. But in the end, after triggering or submitting this task to be executed, we are also going to update the this dot detect running dot get an update. And here, let me get what we need. We basically have a unary operator, which is a function of, okay, is a function of future from future. So what we are going to do here is going to have f, it's the future of itself, oops, not this. Then we are going to basically cancel it, and we are going to return the f itself. So that's basically it. And now we have to change the rule as well. So we are going to run run the while until this dot detection running dot get is different from null. We can also do the same thing here, or we can also get, let me check, compare, exchange. We can check the methods here. Yeah, no, never mind. So it shouldn't be null because we already have started that here. No, we shouldn't. No, we didn't start it. So we started that here first. So this could still be null. So let's say if this guy here is null, or different from null, we need to, then we can run, and this dot detection running dot get dot is not cancelled. If this guy is not cancelled and this is not null, then we can basically go and run it. On the stop, what we're going to be doing is this dot detect. So first we get a check is this dot, let's call it, get this same method here. So process running, then we check if process running is different from null. If this is different from null, what we are going to do is process running dot cancel. In fact, what I did, I think I just did the whole totally wrong logic here. So here we are going to execute. We are not going to get an update. We are basically going to set. There's no reason for us to do that. That's another logic. I'm just confusing stuff, and you guys are not telling me anything. But that's fine. That's fine. That's okay. Then here we basically do and cancel it. So not complex execution here. So as soon as we start, we get the feature and we set the feature inside the detection running atomic thing. And then when we stop, we basically get the value from this atomic reference. We check if it's not null. If it's not null, we basically cancel it. That's it. So for us to finish our class, to make sure that this is working, let's just make a test here. So let's create a class. It's going to be inside service.detection, and it's going to be called FakeDetector test. Then public void should. First thing we are going to do is should start detector if not yet started. Okay, so first let's create our new fake detector. This we need what again? We need first the lane. So let's create a new lane. UID.random UID plus equipment. Oh, we also need to create an equipment. Okay, so I have the lane, new equipment. Equipment has just the UID right now, I think. Yep. So the lane is the lane is just the identifier. So let's call it 0. Then we have the equipment. After that, what else do we have? Then after the lane, we have the processor itself and the executor service. So here we have the detection, so the process, and let's here call the executor service executors.single thread executor. That's it. So here we're going to have the detection. What I'm going to be doing here, have my final var detector, and here I'm going to be calling detector.start. And simple way for us to check. We can also add this as a I think that's a nice practice for us, because it would also make sense to have a method here. We could for sure come here in the test and say, hey, let's for example create a variable here saying like is running, for example, var is running, or boolean is running, is running. That's something we can do. We can say it's false. And if we receive something here, what we are going to do is we are going to be calling is running equals to true. That's something we could do, for example. Why this is not? It should be final. Yeah, okay, got it. Yeah, we could use atomic value, atomic boolean, for example, if you want. But for example, let me just explain that to you. We can use atomic boolean, which is going to have false as default, and here we basically come and say set true, fine, and we start. And after we start, we come and check if assertions dot assert we have assert true, and we have is ready. So we could check something like this. Oops, dot get. That's one way we can do. Let's see. Yeah, it's not going to happen because there may be a time, right? It's running on a thread. So let's, for example, fake it sleep off 1 second. Hopefully it should be running. Should be enough time for us to have a detection. Yeah, as you can see, so the detection is being called, and we can get something. Another way for us to do it, which may be simpler, maybe cleaner, is to have a boolean here is running, which makes sense, right? If you have a detector, you would like to know if the detector is running or not. So your fake detector can also have an implementation to decide whether the detector is running or not. So let's have the solution. So here what we are going to be doing is we check, we get this here, and we check, we basically return if this is different from null and this dot is not cancelled. So in fact we can even refactor our code right now. We can come here and say, hey, you know, if this is running, if this, and then I change the logic for sure, if this is running, I will not do anything, I will just return. Remove this code and we even do some refactor. So first we check if is running. If it's running, we don't do anything. If it's not running, we start to set everything. And here on our code, what we do right now, we remove that workaround. We don't need any logic here. We basically get the detector dot oops, whoa, is running, and we check it. Let's start. That's it. So now we don't even need to understand to have this shouldn't have, because the running should be automatically. And now, for example, if you come and say, hey, detector dot stop, then the assertion should be that it should assert false. It should not be running. So let's check if it's working fine. It's working fine. So let's add a problem like here. For example, let's have let's try to not start it or not stop it. Yeah, that's not going to happen. But let's say like this. If we remove this, we don't start, but we check if it's running. Then it fails. Well, I think that's it for today. So I don't want to make the videos very long. I think this one is already quite long. So, but I will stop here today. So we have done the very basic setup of our project with some definition of some domains, also some small tests. I'm going to be pushing and creating one different branch or different branch on the repository for each class, for each new video, so you can follow up and you can pick up from whatever video you were. I hope you liked it. I hope this video was nice, so you enjoyed the exercise. But we are still not going that deep. We are just like defining our application. And next class, what we are going to do is to really create the fake logic of the detection integration, and we start to set up, to think at least, let's first start to draw how our API is going to work, and then on the next class we start to implement our APIs and integrate them. Okay, I hope you liked it, guys. See you in the next video. Bye bye.